We're Team BiliDx, and our presentation is titled Conjugated BiliDx, Low-Cost Point-of-Care Device for Diagnosing Liver Failure in Newborns. The goal of this project is to adapt BiliSpec, a RICE 360 point-of-care device, to measure conjugated bilirubin. We incorporated a diazo reaction into a paper assay test strip to give a colorimetric change measurable by a spectrophotometer. Bilirubin, in general, is a waste product made by the breakdown of red blood cells, where heme is released from hemoglobin. It enters the liver in an unconjugated form that is water insoluble. After entering the liver, it is then converted into a conjugated state through the addition of a sugar group, which is water soluble and can go through bile and be processed through the colon. Measuring conjugated bilirubin is important. Conjugated bilirubin is likely due to cholestasis, an obstruction of the bile duct, which prevents bile flow and secretion. Because of this, conjugated bilirubin re-enters the blood and results in elevated serum concentrations. A common cause of cholestasis in newborns is biliary atresia, which is when the bile ducts in the liver don't develop properly and, therefore, prevent bile from exiting the body. If diagnosed early enough, preferably within the span of 1 to 6 months, this can be treated through surgery or endoscopy, which is invasive but not nearly as expensive or risky as a liver transplant.
Currently, in high-resource settings, bilirubin analyzers are used to determine total serum bilirubin, which is a measure of both direct and indirect bilirubin. However, these devices cost over $15,000, making them infeasible for use in low-resource settings. There are a handful of devices currently available in low-resource settings, including BiliSpec and BiliStick, but these do not have the ability to measure conjugated bilirubin levels. We determined that the best solution to our challenge is to implement a paper test strip, specifically one that utilizes a colorimetric reaction. The idea is that when a blood sample is added, the conjugated bilirubin molecules present in the blood react with reagents on the test strip, resulting in a color change. Using a spectrophotometer, this color change can be quantified into a light absorbance value that directly correlates with the conjugated bilirubin concentration. Here we have pictured the results from our proof of concept testing using wet reagents on cellulose squares. This initial test shows that the diazo reaction will occur on a paper assay test strip. Additionally, the qualitative color change visible to the naked eye illustrates that this reaction is concentration specific and will have colorimetric values that parallel the test strip's respective concentrations. Thank you so much for listening to our video, and we'll see you soon.